All right. Hello again. Um, may not be a while, may not have been a while since you've seen me, but it's been a while since I sat down. So today we are going to look at new stuff. And the first new stuff we're going to look at is called the empirical rule. And what it is about is using a normal bell curve and finding probabilities that are already standardized. And kind of going back to what we talked about before, probabilities. Probability. We know it can be written as a fraction, a decimal, or a percent. And we've seen this, we've done it, not too bad. So let's say that there's 20 of you watching, and 5 of you are watching this while sitting on the toilet going to the bathroom. So that's a probability that 5 out of 20 of you are watching this while doing your business. Okay, so that's the fraction form. And then we change it to decimal form. We take 5, we divide it by 20. Make sure I don't screw this up. We get 0.25. So decimal form, 0.25. Percent form, you always take that decimal and move it over 2 spaces because we multiply by 100. So move it, 25%. So this is our data displayed as a number. We can also display our data as a picture, and we've all seen this at some point. So picture form, I can represent 25%, ooh, that's kind of bad, 25% and a circle graph, right? So 25%, kind of eyeballing it, is about, yeah, it's kind of close right here, right? So if I were to ask you, hey, what's the probability of selecting someone looking at this graph of sitting on the toilet watching this video? And if you know that this is the red means sitting on the toilet, you'd say, oh, about 25%. Cool. So if 25% is here, how much is right here? Hopefully you said 75%, right? So if this is 25%, that means this is 75%. And where do we get 75% from? Right, hopefully you said that we know that all of this has to equal 100%, okay? So when we take probability and percent-wise, we're gonna take this percentages, this 100% graph, and we're going to make it into something that looks like this. Whee! All right, that's my good freehanding it. So later we'll talk about all those curves you're seeing in the news about flattening the curve. You saw those big, tall bell curves, and then the flatter one. So we'll talk about that later, but for right now, we're just gonna assume that this is an everyday kind of thing, and we're talking about what's called a normal bell curve. Okay. So in a normal bell curve, sorry, just like this was 100%, all of this, oof, not shading very well, all of this equals 100%. And what they refer to that as, when we look up answers and we use values, this is referred to as, rather than a shaded area in a circle, they call this the area under the curve. And that area is going to be a decimal value, and that decimal value is a probability. So we're going to use this to find probabilities, or percent, either way. Okay, So we get a normal bell curve when we look at something that is, even Stevens all the way around. So if you recall when we did that example of mean, median, mode for our toilet paper usage, this is why. So when we did our number of months before people ran out of their mass quantities of toilet paper, this was in the review video. We found the mode to be 35, we found the median to be 35, and we found the mean to be 35. And what that tells us is that we have a normal bell curve, like that. So the mean, median, and mode are all the same value, and that's all in the middle. All this means is that you're going to see phrases called this blah, 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 normally distributed. That's what that means. It's not something that looks like this. Nope. And it's not something that looks like this. That's no. So we're talking about something that is symmetric. So when can we use this? Well, we can use this lots of times. So the empirical rule is kind of what I was starting with. Means that we're going to have our set standard deviations, and within those set standard deviations, then we have our set probabilities. Okay, so the mean, it always goes in the middle, and then we have our data is by standard deviations. Okay, so this is one standard deviation to above the mean, 2 standard deviations above the mean, and 3 standard deviations above the mean. So you can be above the mean, you can also be below the mean. So we have 1 standard deviation below, or 2, or a little bit more than 3, 3-ish down there, and 3-ish up here. Okay, so what this means is that if we have set values, 1, 2, 3, we can get answers to probabilities using this data, because there's a set rule. So the empirical rule is also referred to as a 68, 95, 90, 9.7. I knew that. Sorry about that. So typically we see that 34% of whatever you have is 1 standard deviation above. And since this is symmetric, 34% is below. So if you add those two together, you get 68%. So no matter what it is, if your data is normally distributed, whether it's IQ testing, whether it's heights, whether it's birth rates, whether it's death rates, shoe sizes, whatever, 68% of your population or your data will fall 1 standard deviation above and 1 standard deviation below the mean. Okay, that's what it is. You can also be 2 standard deviations out, and that's a little bit more. So this will be, probably should have looked this up before I start talking, 13.5, and then 13.5% there. So when you take that 68% and add in this extra, that's how we get 95%. So what that means is that 95% of your data is going to fall um, between 2 standard deviations above and below the mean. So it's almost everything. Not quite everything yet, got a little bit more. And then here, we're going to have, usually what you see is that little extra here, 2.35. And then there's a tiny little bit left over, 0.15. 0.15. Sometimes if you Google these pictures on, Google, you might see these being added. So you might see 2.5, 2.5 rather than separated. But there is that little extra at the end there. When you get into statistics, it gets a little decimally. So this is what they tend to use. So right here, if we added up everything, 3 standard deviations out. So we took 95 and we added this 2.35 and that 2.35, we're going to get 99.7. And statistically, it's very, 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 very difficult to get beyond that. That's why this probability is so low. But if we were to add this up together, all of this added will equal 100%. So this is also symmetric, meaning that if you cut this in half evenly, right? This is your bottom 50%. And this is your top 50%. Now, I'm not saying bottom and top as far as judgment. Something like that. Sometimes it's good to be in the bottom 50% rather than the top. Like maybe virus contractions or whatever. When you get the virus, you'd rather be like no, right, rather than high. Sometimes it is good to be in the top part. Like if you score well on a test, you'd rather be up here than down here. But again, this depends on what test that is. Your your test that you take at school, you'd rather it be down here. If you took a DUI test, you'd probably want to be down here, right? So again, it's all about context. All right, so that's a crash course in using a bell curve with given percents and standard deviations. So our next video is going to talk about actually using our mean and a value that are for a standard deviation in order to use this, okay? All right, so I'll see you in just a minute.